we send current into the ground in electrical resistivity method. The current that we are going to send into the ground comes from somewhere. Where the current is coming from is the transmitter. The current will now go into the ground. That current we sent into the ground will encounter or will interact with something in the ground, which will now make us to measure potential at 2 points. The potential at 2 points that is being measured will now be sent from the ground to the surface of the earth through what we call a receiver. So we always have a transmitter, we always have a receiver. A transmitter sends signal into the ground. When that signal reaches the targeted place, it will be sent off into the ground surface. When it goes into the ground surface, something will pick it from the ground surface. That is the receiver. So how close or how far the transmitter and the receiver are going to be is also very important to us. So we must know the optimum position between the receiver and the transmitter. Closely connected to the position of the transmitter and the receiver is the depth that we are interested in. If we are looking for groundwater, I will always emphasize groundwater because that is my area, or one of my areas of interest. If we want to detect groundwater, where we are going to get groundwater also depends on geological setting. In some area, groundwater is obtained close to the surface. Elsewhere, we have to dig so deeply before we can get water. So the depth to which the target is buried is also very essential. So we also need to ask ourselves, what depth into the subsurface are we interested in? Or how deep into the earth is that target buried? How are we going to address the issue of depth? This is also what we are going to look at in survey design. We also need to look at what kind of target are we interested in? Is that target a very small target? If the target is very small, what distance can the antenna and the receiver be? If the target is so deeply buried into the ground, what will be the distance between the transmitter and the receiver? If, for instance, the target is close to the ground, and we now use a very big distance separation between the transmitter and the receiver, when we carry out that survey, we conclude, or we may conclude, that there is no target in that place. Because what our result is showing that there is no target. It may be so because the spacing we have chosen is wrongly selected. The target is close to the surface. We are now using a very big separation. We are going to miss that target because we have not used an optimum separation to map that target. that issues is what we call aliasing. So we are going to commit what is called aliasing, where the target is there. Because we have chosen a very wrong survey parameter, we say that the target is not there. In some other situation, we may use very small separation. After the survey, we conclude that target is not there. After the survey, we conclude that the target is not there, whereas the target is there, but we have used a very wrong survey parameter, and that enables or makes us not to see the target. So all these are very important, that we need to the depth to which the target is buried. In addition to that, what are the physical properties of the earth are we interested in? What physical property of the earth are we interested in? For instance, if we want to see density varies from one place to another, that variation in density is the physical property we must use in what is called electrical resistivity survey. So it is important that whenever we are embarking on geophysical survey, we should have proper understanding and selection of our survey parameters. The selection of our survey parameters will enable us to attain optimum results. And if the survey parameters are not carefully chosen, then the geophysical data that we have gathered, they are going to be noisy, they will not add meaning, and the time and the cost that we have spent to acquire the data will just go into the wind. So it is very necessary that when we are embarking on geophysical survey, we must ask ourselves some of those questions that we have raised. They are very important. In addition to that, we can also say that the geology of the study area is also very important. Please, can you mute yourself, please? The geology of the study area is also very important. We must know the geology of the area where we want to carry out our survey. For instance, I want to make reference again to electrical resistivity method. We want to carry out investigation somewhere in Ojota or Oregun precisely, where we have dump sites. We want to see the state of water, groundwater in that area. There has been agitation by the people in that neighborhood that the groundwater they use has been contaminated because of the landfill in that area. As a geophysicist, we have to carry out that investigation. We also need to carry out, among others, electrical resistivity survey. When we carry out electrical resistivity survey, what's the liquid which is poisonous which is toxic, that comes from that refuse or rubbish they dump, is what we call leachate. And that leachate is so poisonous that it must not be allowed to get into groundwater. If it does, as little or small as it may be, if it gets to the water table, then it is a threat to human life. Anyone that drinks from that water may likely have some health issues. So we are saying that it is also important that we understand this geology. Now, having collected the geophysical data, because of that liquid that is poisonous, it will show a low resistivity. If I do not know the geology of Oregon and that data comes to me, once I see low resistivity, I can say that resistivity can mean something else. The low resistivity, I can say, can be as a result of saltwater intrusion. The low resistivity, I can say, can be due to clay and all that. All of them, they have low resistivity. So if I do not know that that data was collected from Oregon, then we make a mistake by saying the low resistivity that we have seen is as a result of saltwater intrusion and not leachate. So it is very important that we know the geology of the area we want to carry out our investigation. And that is what will make you a better geoscientist, because in the department, you are going to take some courses in geophysics. You are also going to take some courses or much more in geology. So that is aimed at strengthening your knowledge as regard geosciences. So how much will the survey you want to carry out, how much will it cost, is another thing that we need to take into cognizance. Having said that, as regards survey, what do we want to detect in the subsurface? What do we want to map in the subsurface? What do we want to reveal in the subsurface is another thing that a geoscientist must bother himself with. Can we actually detect that anomaly in the subsurface? Can we actually detect where groundwater is in the subsurface? Can we actually locate where hydrocarbon or oil, crude oil, is in the subsurface? So detectability is another issue that we need to be bothered with. How detectable are or is that target in the subsurface? So we have to give priority to detection of the target, which we call detectability. In order for a target to be detectable, in order for a target to be detectable, then we must know what are we sending into the ground and what are we receiving from the ground. In order for the target to be detectable, we must also know the distance between how is the transmitter and the receiver, how are they separated? we must know the separation between the transmitter and the receiver. I want to be specific now. I want to carry out a survey and I'm using electromagnetic method. If I'm using electromagnetic method for detecting an object in the subsurface, I will need a transmitter. I will also ask for a receiver. The transmitter is what we send signal from the instrument into the ground, and when that instrument gets to the detector, when it gets to the target will modulate the signal. So that signal that comes from the transmitter to the target is what we call transmitter signal. I hope that is clear. The signal that comes from the instrument that signal that comes from the instrument and it goes into the ground until it is being detected is what we call primary signal. When the signal gets to the target, so the separation between the transmitter and the receiver is very important whenever we are embarking on survey. So we know we have an idea of what we call primary feed. Primary feed is that feed that comes from the transmitter and enters into the ground. When it reaches the ground, it gets to the target. When it reaches the target, some modification will be done to it. From the target, the signal will now get to the receiver. So that is what we call transmitter signal or primary feed. Primary feed is that feed that goes from transmitter into the ground and gets to the target. The signal from the target that also encounter other materials, that signal from the target, if it is now sent into the receiver, it is called secondary feed. So we can also define primary feed as the feed between the transmitter and the target. That is primary feed. The feed between the transmitter and the target. The feed between the target and the receiver is what we call the secondary feed. The feed between the target and the receiver, we call it the secondary feed. So these two feeds are very essential when we are mapping the subsurface. Since have been unable to project, I think we can stop the class here. Hopefully before the weeks run out, we can look for another time to have it. Let me see what I can do to my laptop as well, because things I want to do now is good if I project them to you so that we can have a better understanding of it rather than just talking without being projected. So because of that, I think we can call it a day now. I will look at what is actually wrong with my laptop so that we can have the class before Friday, on or before Friday. So if you have any question based on what we have said, feel free to ask me. Can you ask me if there is any question?
Sorry, good morning, sir.
Yeah, how are you?
Yeah, fine, sir. Good morning, sir. Sir, and the last class we had, there's a particular passcode there. We are unable to log in because we do not provide the passcode, sir.
You said?
The last class we had for GPH, there's a
Yes.
passcode login there. We are unable to log in, sir.
You said?
The passcode, you haven't dropped it
Eh,
yet, sir.
the passcode for,
The last class,
yes, what happens to it? It's the same passcode you are using for this